Hello everyone, myself Kamna Singh, Assistant Professor in Computer Science and Engineering Department in Garg Engineering College. Today we are going to discuss about the pipelining method in computer organization and architecture subject. Actually, what is the pipelining? When you are thinking about the pipelining, the simple phenomena is there that there is a water are flowing in a pipe, and these particular water droplets is communicate next, and drops are going on. The same concept is applying in the computer organization and architecture methods, that is the pipelining. If in a simple words we are saying that the pipelining is what? Pipelining allow the multiple instructions stages to be executed simultaneously, and that it improves the CPU performance and efficiency of the overall system. Or you can say the pipelining method, if I have imagine there is a modules of your project. Simple. There is a 4 modules in your project. That first module, you can say there is a M1. The second module is of M2, and the third module is M3, and fourth module is M4 in your simple project. Fine. So in the first module, you are actually the complete project is segmented in these 4 modules, and these 4 modules are computed by the different persons, suppose. So this is the complete project. Actually, you can say this is the complete project, and this complete project is bifurcated by the modules. Now when we are going to apply this particular concept as a pipeline method, so the M1 is what? In the M1, whatever M1 input is there and then output is created, that output is going to the next module and treated, this output is treated as for the M2 as an input value. And the next again the same procedure will be followed. That is in the M2, whatever output is generated, that is treated as an input for the M3 module, and so on. Means like this for the M4 is also applying. So you can say the pipelining is what? To overall module or overall task is to be segmentized with a different segments, and these particular segments created some input, taking some input and created some output, and these output will be treated as an input for the next segment. So this is the simple phenomena for the pipeline. So you can say the pipelining is a technique for the multiple instructions are executed simultaneously as a pipelining method. So these are the stages of the pipelining. There are 5 stages of the pipelining. The first is the instruction fetch. Instruction fetch means that how the particular instruction is coming from the memory. Memory having all the instruction, that is a permanent storage locations where all the particular data or information are stored. So these particular is coming from the instruction fetch. You can see here that is there is a memory is there, and this memory there is a fetching the instruction, and this will be going to the instruction register for fetching the instruction. So CPU fetches the instructions from the memory and stored in the instruction register, and generally instruction register is of 16-bit. Now the instruction register having the instruction, now decode that particular instruction. Generally decoding of the instruction will be coming out D0 to D7 or a 8 operations will be there. And the next stage of the pipeline is execution. Actually the operation is performed with the ALU computation, whatever the plus, minus or add, divide, whatever the operations will be there, all the opcodes will be performed here in the execution phase. And the next is the memory. Memory access means MEM is the memory access. Data is written to the memory. In the fetch instruction, you are getting the instruction from the memory and stored in the instruction register. But in the memory access means you have a data, now you are reading that data, and if any update is required, you are modifying that. And then after that modifying, this particular replace to the again to the memory. Means write back means the result is written back to the register or a memory. So you can simply say that in the stages of the pipeline, the first you are fetching the instructions from the memory and stored in the instruction register. And then after that instruction register, there is a decode operation will be applied here in the instruction, and then executing the instruction, this decode instruction. After that, there is a execution of the instruction, and then the output will be generated, and whatever output is there, it is right back to the result is written back to the memory or a register. Register is, you can say, that is a temporary buffer. Now, these are the advantages of the pipelining. If we say that is the increase instructions of the throughput, means more instructions per unit at a time. If we are not using the pipeline system, or you can say the non-pipeline system will be there, so you are executing, suppose that there is 100 tasks. In 100 tasks, you are 100 times you are executing that instruction. So the here in the pipeline system, because the instructions is to be segmented, so the more instructions per unit time and the throughput will be increased, and it increases the CPU efficiency and the speed also, and reduces the idle time, whatever that idle time which is to be, suppose that the 100 tasks you have to execute it within the 50 seconds, but when you are using the pipeline method, so maybe possible it is only taking the 10 seconds, or for all 100 tasks will be there. So it reduces the idle time of the CPU component. Now, there is a pipeline system and there are so many processes there, but the cons is also there. What are the disadvantages? That is the pipelining. These are the disadvantages of the pipeline. Is there is some hazards are also there. Data controller or structural hazards will be there, and there is some complexity of the design and control logic, and there is all instructions equally from the pipelining. So let's discuss about the pipelining processing. In the pipeline processing, it is a technique used to enhance the performance of by dividing the task into the multiple stages in parallel. Means what? As we discuss here, that all these particular project is divided into the multiple tasks, and these multiple tasks will be executed simultaneously, and then next output is there. This output will be generated. Here is the input. Then input taking here some input, taking some output in this. After that, there is some output will be generated, and for the next module, it is taking as an input. So now, let's take an example. Suppose that we have to use as then, suppose I have to written as A plus B plus C. Suppose, or we can take an example, that is A into B plus C. Suppose we have to take this example. 3 values are there, and the some result is stored somewhere else. Suppose in the Y, the result will be stored. So A into B plus C, these are your, here are 3 operands are there. A, B, C are the operand, and opcodes are 2. This first, there is a multiplication, and the plus is the addition. Means what? Suppose that if this particular operation is performed in a single time, so that is okay. Suppose that one single time executed, your result will be getting out. This result is treated as in the 1 second. Suppose if it is computed and result will be coming out in the 1 second for this particular instruction. If I am saying the complete instruction A into B plus C should be executed at least 7 times. The same instructions will be followed, but it should be executed at 7 times. Means this is the instruction that is included, that is executed at every time it is to be repeated. So how we are going to execute this? We can write it here AI, BI and CI. So here I value is what? I value is started from 1 to 7. So every time the instruction is executed, A1, B1 and C1, then A2, B2 and C2 and A3, B3 till 7. It is written over here, AI into BI plus CI, where I equal to 1 to 7. First, for the pipeline process, when we are starting the pipeline, whatever value is there, means whatever the operands are there on which we are going to apply the operation, here the operations are there. Here the operations, and the first First is what? How you are getting the instructions. You can say in this particular pipeline, because two opcodes are there. Two opcodes are there, so that there is a 3-stage pipeline. You can calculate the opcodes 1, 2, 3, whatever opcodes in your instructions. If there is a 2 instruction, so there is a 3-stage pipeline. If there is a 4 instructions, so 5-stage pipeline. Or agar 2 instructions, then 3. So here there is a 1 and 2 opcodes are there. Because the 2 opcodes, so there is a 3-stage pipeline. Why? Because in the first value, you have to convert this R1 is to, in this particular AI, I have an instruction is AI into BI plus CI. In the first stage, this AI goes to the R1 and the second BI goes to the R2. You can take any register, R1 to R7, any register you can take. In the AI is goes to here. So you can see here AI goes to the R1 and BI goes to the R2, because on that particular operand we cannot include the directly to the operand. We have to store this particular operand into the registers. In the second stage, what we are going to do, here is the multiply operations. So for the BODMAS rule, first we are applying the multiply, after that the addition. So multiply operation, R2 to R1, there is a multiply operations will be there, and this particular, suppose that in the multiply operation, what you are going to do, there is a multiplier you can use, whatever the circuit you are using, because of multiplication, so you can here use as a multiplier. This particular result going out here, and whatever the result is coming, this value will be stored in R3. R3 store R1 into R2, and at the same time CI will be stored in the R4. Simple. This CI will also be stored in the some register, so there is a CI. Now whatever result is coming from R3 to R4, now you can use the what? Which particular circuit you are going to use? What is this? This is the plus. The plus means adder. You can use here as an adder, and whatever result is coming out here, you can use R3 plus R4 and the result will be stored in R5. This is a simple process of this particular instruction. If the instruction is there, AI into BI plus CI, where 2 opcodes are there and the 3 operands are there. 3 operands and 2 opcodes. If the 2 opcodes are there, it means we have a 3-stage pipeline will be there. And here it is written over here, how many times the pipeline will be executed, that is the 7 times. Now the same procedure is display here, that is in the first time AI goes to the R1, the BI goes to the R2 and the CI goes to the R4. Next, what the instruction is what? AI into BI plus CI. So AI into BI executed first. R1, R2, multiplier, because the multiply operation is there, multiplier. If there is a some division operation or a minus operation is there, so you can change accordingly about the circuit. Next, R3 is there and CI is the R4 goes to here. The adder will be adder. Why we are taking the adder? Because this result, whatever result is coming out, in this particular result, CI will be added. That's why adder is there. If there is a minus sign will be there, the subtractor will be there, and the result is coming over here as an R5. So simply you can see here in this particular pipeline simple process, this is a block diagram for the pipeline process for the AI into BI plus CI. So first load AI will be there and the R2. Next result will be stored and this particular result will be added into the CI. Now the stages of the pipeline. In the stages of the pipeline, how we are going to calculate with the stages of the pipeline. Suppose that there is a how many stages are there? Segment 1, 2, 3. You can see here there is a 1 segment, 2 segment and the 3 segments is there. Fine. So in the first stage, you can see here there is a segment 1, R1, R2, R3, R4 and R5 is there. In the first clause, first clock pulse means, clock pulse number means every tick your particular operation will be going to be executed. In the first, R1 means there is a what? AI into BI plus CI. So in the first tick, AI will be stored or A1 will be stored in R1. And in the R2, what? B1 will be stored in the R2. Here R3, R4, R5, there is no values will be stored. In the second operation, what will happening? In this particular time, again, the A1, B1 is already here. So in the R3, A1 into B1 will be stored. A1 into B1 is stored. And in the R4, there is nothing, values are there, and this value will be there. In the third operation, there is a, at the same, this particular line, A1 into B1. At that moment, because the previously there is a registers are free, because the A1, B1 is going to the R3, the resultant will be stored here. So these particular value operations will be free. The previous are free, that is okay, but there is no values are there. But in the R1 and R2, the previous operations, previous register will be free. So here A2 and B2 will be coming and A1 into B1. Next, in the third operation, A1, B1 resultant will be stored where? In the A1 into B1, the result will, A1 into B1, the result will be stored here in the R4. And next, this particular value, A3 and B3 will be coming out here. At the same time, the R4, here, there is a C1 will be stored. The same procedures will be followed one by one. After that, the A7, we can reach the A7. Now you can see here in the A1 into B1, A2 into B2, because the previous slides were register were free, A1 into B1 and C1 in the second stage. And the third stage, A3 into B3 will be there. This value will be stored here, A2 into B2, and next is the C2. The result will be stored in the R5. The complete result will be stored after the third operation. You can see 1, 2, 3. The R5 will be coming out after the third stage. Because we have the A7 value, so we have to executed this particular operation till the A7 to B7. Till the operation. So you can see here A3 into B3, next A4, next, and so on. Now, generally, what is the 4-segment pipeline? These are the execution of the pipeline, or what are the operations in each pipeline. And now, if in a question paper, there is a 4-segment pipeline is there, or a 5-segment pipeline. It means what? Segments you can read it here, like S1, S2, S3, and S4. Segments are there, and each segment is going to store in the register. As you see previously, in each segment, whatever the segment is there, this will be stored here in the R1. Then this particular, whatever the result is coming out here, this value will be stored in the register. So every time each segment will be stored here in the register, and you know that in the register always there is a clock pulse is there. So for the 4-segment pipeline, you can see here input S1, 1, 2, 3, 4 segments, and each segment result will going out here, R1, R2, and each register having a clock pulse. Suppose that, let's take an example. If you have to create the 2-segment pipeline, you have to create 2-segment pipeline. It means what? Simple. S1 and S2 will be there. There is a first S1. This value will be stored in the R1, and next is the S2 will be there, and R2 will be there. And because there is a registers are there, so each register there is a clock pulse will be there. You can see here that is the clock, and simple there is a input value. So this is the simple 2-segment pipeline. If in a paper there is a 8-segment pipeline, it means what? 8 segments will be there, 8 registers will be there, and each register you have to input as a clock pulse. Now this is the space-time diagram for the pipeline. It's very, very important, space-time diagram. Suppose that, let's take, there is a 4 segment. Suppose that in the question, you can ask, there is a 4 segments are there. This particular 4 segment having a 6 task. So you have to calculate to complete for an complete execution of 4 segment pipeline, what will be the time? The time will be calculated by the clock pulse. Clock, whatever the clocks will be there, so clock pulses will be there. So at the starting, what you have to write, there is a 4 segments are there, fine, and the 6 task is there, and you have to calculate the clock time, or you have to calculate how much time to complete these 4 segments. So you can see here, simple 4 segments are there. These are the segment. Ye first segment is there, second segment, third segment, and this. And this task can be written as T1 to T6. So for the first segment, each segment having a 6 task. So for the first segment, the complete execution of the first segment, we have to execute all 6 tasks. So simply you can write T1, T2, T3, T4, T5 and T6. Because from the first clock, this is the clock pulses. In the first tick, T1 is also executed. When the second segment is going to be executed, the second clock will be executed from here, T1. Just remember this particular line, that because of the first tick, or you can say first second, the first segment will be executed. So the second segment will be executed at the second second. So in the clock time, T1, T2, because there is a 6 segment is there. So T5 and T6. Next, third segment. So you can say in the third time, T1, T2, T3, T4, T5 and T6. And the fourth segment is the last segment. It will be started from here, T1, T2, T3, T4, T5 and T6. Now you have to calculate the clock time. Clock time is 6 is already here. There is a 7, 8 and 9. So the answer is what? Your answer of the number of clocks required to complete the 4 segment execution is what? 9. 9 clock cycles you required. This will be your answer. Simple. So in the space diagram, you can see here the 4 segment and the 6 tasks. So 9 clock cycles to complete the pipeline. If there is a, this is for the pipeline system. Without pipeline, what will be the time will be taken? Because the 4 segment is there and the 6. So for the, then the clock time will be required was 4 into 6, that is 24. And in the pipeline system, there is a 9 clock cycle. So it is execution time will be decreased and the efficiency will be increased for the pipeline system. You can see here with the help of the space-time diagram. Now, simple terms are there, some terms of the pipeline method. K is the represented with the segment pipeline. N is represented as the number of tasks. TP is the clock cycle time for the pipeline system. And K into TP is to complete the task of the one task, T1. And the K into TP is to complete the remaining task, whatever the task will be executed. And the N minus 1 into TP is to complete the remaining N minus 1 task. And this you have to remember, K plus N minus 1. K plus N minus 1, that is a clock cycle time to complete N task with a K segment pipeline. With this particular example, K plus N minus 1, you can easily find out without a space-time diagram. You can find out for the pipeline system, if you calculate the K plus N minus 1 for the pipeline system, K plus N minus 1. So it means what? Number of K plus N minus 1. So you can see here, K is the segment. So K segment, 4 segment are there, plus N minus 1. N is what? 6 task here. N is the task. So N is the task, you can see here, that is a K plus N minus 1. That is the 6 minus 1. That is what? 5. Directly you can get the 9 clock cycle without using the space-time diagram with this particular formula, K plus N minus 1 for the particular pipeline system. And now the pipeline best cases, and T1 is that complete n task without pipeline. Now, these are the speed up ratio. Speed up is generally, you can see here, that is the speed up is generally calculated with the help of the non-pipeline system with a pipeline system. Non-pipeline and pipeline system. So, you can see here Tn is the time to complete task and the tau1 and tau2 is also there and the speed up ratio. With the help of the some example, you can see here, suppose that this is the example, suppose that there is a 4-stage pipeline. 4-stage pipeline means what? N. N value is given, that is 4. And sub operation in each stage is 20 nanosecond. So, the TP is also given, that is a 20 nanosecond. With the pipeline, the clock cycle time is given. 100 tasks to be executed. This is the question actually. The 100 tasks to be executed, it means what? 100 tasks means what? 100 tasks means K value is given. 100 is there. Now, one task in non-pipeline system taking the 80 nanoseconds. What will be the speed up? Speed up is always the non-pipeline system and the pipeline system ratio. In the pipeline system ratio, you can easily calculate with the help of the K plus N minus 1 into TP. Here, K is what? 4. N is what? 100. 100 minus 1, 99. So, 4 plus 99. And the TP is the for pipeline system. For each task, it will take 20 nanoseconds for each task. So, how many total number of tasks is here? This one. So, into 20. This much amount of time will be required for the pipeline system. And for the non-pipeline system, N into K into TP. As we can calculate it with the 4 task and the 6 segment, same procedure will be followed here. That is a N into K into TP will be there. That is 100 into 80 or a 8000 nanoseconds. Then the speed up ratio is S of K because this is the 8000. So, 8000 divided by 2060. That will be the speed up ratio. Or you can say the efficiency of the cycle. Now, this is the simple example for the non-pipeline processor. This is the question. For a non-pipeline processor, takes 5 cycles to execute an instruction. 5 cycles means what? How many non-pipeline system? 5 segments with the task. So, there is a clock cycle time is 5. Then the pipeline processor with the 5 stages. 5 stages means what? What is given? N. N equal to 5. And the instructions per cycle of the pipeline is full and the total number of instruction is executed is 100. Means total number of tasks or a K value is there. Means what? There is a N value is given 5 and the K value is given 100 and the TP value is there 5. 5 cycle per second. You can calculate again. K plus N minus 1 into TP. The same procedure will be followed for non-pipeline system because there is a what? N into 5. So, for the non-pipeline system, N into K. For 500 cycle will be there. And the pipeline filling time plus remaining instructions will be executed. That is what? K plus N minus 1 into TP. So, here what? K minus 1 plus 100 because 100 task will be taking out. So, 104 cycles will be there and the speed up ratio non-pipeline upon pipeline. Non-pipeline taking the 500 and the pipeline having the 104. So, there is a speed up ratio is the 4.81 ratio. These are the pipeline applications. These pipeline applications will be here. That is the arithmetic pipeline and the instruction pipeline. In the arithmetic pipeline, there is a dividing some operations and executing and the instruction. Some instructions is coming over here from the memory and then fetching, decoding the instructions and memory access.